Video discusses writing R functions. So just to recap what we've done so far in the course, we've talked about common data objects that you might run across in R and how to access them, how to get to the different pieces. This is going to be really important for our function writing piece to understand, especially lists, because we're going to utilize those a lot here. We've talked about using R Markdown as a way to make your entire workflow process reproducible, as well as communicate your final results easily. And then we started talking about a little bit more of the nuts and bolts of doing data science, where you have data, you want to manipulate it, you want to subset it, you want to create new variables. So we talked about the tidyverse packages for doing that, and specifically dplyr and tidyr. And so again, what we're going to do now is talk about the idea of writing your own functions. And so functions essentially are going to allow you to put a whole bunch of different work into one easily callable line of code. So, you might have a process where you're manipulating your data and it's an 8-step process. You do a filter, you do a select, you do something else, you do a summarize, you do all these things. And so rather than writing all those different pieces out, you might put that entire process into a function. So then whenever you're actually going to write your analysis code, all you do is run that one line that will do all of that work for you. And so this will just make things look a little bit nicer and be a little bit easier to understand, especially if you name the functions well. So to get at that, let's start talking about how to write your own function. So the syntax is what you see before you. So you actually store your function in an R object. So you put the name of the R object that you want here. This is going to be the name of your function that you're going to use to call. And then you use the keyword function and give it whatever inputs you're desiring from the user. And you can use ... We'll talk more about that later. But essentially here we're asking for 2 inputs from the user. We use curly brackets, and then the code for the function goes in here. And then you either explicitly return something with the return function, or R by default will return the last thing that it executes in that function call. So, trying to write your own functions at first can seem a little bit daunting, but one nice thing about R is that you can see under the hood of all of the other functions that you might be using. So for instance, var is a function to compute the variance. And so if you just type var without parentheses into your R session, so just go var, notice that by default RStudio says, well, you don't want just var, you must want the function. If we get rid of those parentheses and hit enter, we actually see the code that's running underneath for var. So you can see that they use the keyword function. The inputs are given here. Notice that some of these have an equal sign with a value. Those are default values for those. X does not have a default value, so you must supply that. Y could be nothing. It could be null, empty. And then na.rm is by default set to false. And then there's this use argument as well. And so it goes through here, and this is the code that runs. So this gives you a pretty good idea about generally how an R function might work. There's a function called call means, which if you have a matrix, it will find the mean of each one of the columns. And so here is what that does. It has arguments x, na.rm, and dims. And it goes through, it does some testing of, did you give me the right kind of objects? And then it determines how to actually call means from a different, in a different way down there. Some functions, though, are super generic functions. And so like mean is just going to end up looking like this. So this says use method. So remember we talked about that object-oriented stuff earlier on. So this is a sort of a generic function that will act on the type of object that you give it. To be able to see sort of the default, we could just type in mean.default. This is going to be the default method. And so this takes in an x. There's a trim argument for a trimmed mean, na.rm, and then you can add extra things as well. And so this goes through testing of what kind of object you've given it, and then figures out how to take the mean from there. So, if there's functions you've been utilizing as you go, it might be kind of fun to look at what they do under the hood. But let's talk about creating our own function now. So let's make a goal. We want to create a function called standardize that does the following. It takes in a vector of values. It subtracts off the mean of that vector and divides by the standard deviation of that vector. So essentially that z-score idea that you may have seen in your first applied course. And so for a given value I, what I want to do is take the mean of all the values, subtracted from that, and then divide by the standard deviation. So how do we do that? Well, remember that this is our default syntax up here. So if we want to call the function standardize, that's what we give it on the left-hand side here. So we're storing in the R object standardize a function that takes in some argument that we're calling vector. Now that doesn't mean that this thing is a vector. That's just what we're calling it for the sake of whoever is using our function. So you could call this A, you could call it B, it doesn't really matter. You tend to want to give reasonably descriptive names, though. So we're going to give vector as our name for our input. And then within here, we're going to explicitly return the vector minus the mean of the vector divided by the standard deviation. Now, I don't really need to put the return there because this is the only computation I'm doing, and by default, R is going to return that. But I personally like to explicitly return things. Now, the reason that this works is that R does element-wise addition, subtraction, multiplication types of things to vectors. So vector might have 10 elements in it. I'm saying subtract the mean of vector. So mean vector is really a vector of length 1. And so this is going to do element-wise subtraction. And then I'm going to divide by the standard deviation of vector, which returns a vector of length 1. So I'm actually doing element-wise division at that point as well. So we could use it and make sure it works. So here I'm creating 5 random uniform values. You see them there. I can do standardize of data. I'm going to store that in result. So now if we look at result, we can see that the values did in fact change. And one thing we can do to sort of check to make sure that the result has the properties that we should have, remember that by standardizing these, we are essentially setting them at 0, centering them at 0. So the mean of our result vector should be 0, and numerically it is. And since we've standardized them by dividing by the standard deviation of our result should also be 1. So we are good to go there in that aspect. It looks like it's doing what it's supposed to be doing. All right, so that's a basic function. Let's go ahead and customize it. Let's add in more inputs. Let's put in some default values and things like that. So we might want to make, say, centering or scaling optional as specified by the user. So I could add other arguments to my function. I can say for the user, I need them to tell me not only the vector, but a value center and a value scale. And so implicitly what I'm saying here by putting center here in this if statement is that center needs to be a true or false value, or something that can be coerced to true or false. So if center is true, then what we're going to do is take our original data set and subtract off the mean. And then if scale is true, then we're going to take that original vector and divide by the standard deviation. And then we'll return the result. And so now what we need to do is give arguments for center and scale in order for this to work. As you can see, whenever we center them or verse is not centering them, we do get different results. So that's good to know. Now, of course, you probably don't want to require the user to say whether they want to center or scale, because if they're using a standardized function, they're probably wanting to do both of those. But maybe we want to give them the option to say only center or only scale. So this means we probably want to set default values. So to set default values, just within the function definition up here, we just use an equal sign and set the default value there. This is one of the places where we actually do use the equal sign as opposed to the arrow storage whenever you're doing inline function writing and function calls. So we're saying the default value for center is true, default value for scale is true. But we have the same exact code running on the inside. Now, this call up here is equivalent to the call that you see down here. Since center and scale are by default true, we're getting the same exact results whether we put those in there or not. All right, so that's pretty cool. We are now able to return this object. We have default arguments for our user. We might also want to return multiple things though, right? So right now what we're doing is we're returning a single vector, right? We're returning the possibly altered vector. Well, you might want to also return other information about whatever you did. So for instance, here we might want to return the mean of the original data and the standard deviation of the original data. Maybe that way we can back transform if we wanted to. So to return more than one thing, we need to return a list. So the function can only return one object, but if you remember, lists are super, super flexible objects, right? It's a one-dimensional object where each element of that list can be something completely different. But the fact that we're returning a single list means that we're returning one thing. Just that one thing has lots of stuff to it, right? So this is the way to return more than one argument. we use return, and we use a list that we return. So in order to be able to return those things here, I'm actually going to put some code at the top that says, let's go ahead and store the mean and store the standard deviation. And then we'll use those values here, and we'll return the original ones, whether or not we centered or scaled. That doesn't really matter. We'll still be able to return the original mean and original standard deviation. So now whenever I run result on my data, standardize on my data, I look at result. Notice that I returned a list of 3 things, 1, 2, 3. So now I have a list of 1, 2, 3 things. The first one being the possibly centered and scaled data, the second being the mean, and the third being the standard deviation of the original data. And so we know how to access the different pieces of this, right? We would say result bracket bracket 2 to get at the second one. So this would be the mean of the original data. This bracket bracket notation is not pleasing to the eye, and it's not very informative to return these things to your user. So what you probably want to do is fancy up what you're returning by giving it names. So we've talked about having a named list. Well, we name the list by just putting the names that we want for the things on the left. So now I'm going to return a list of 3 things, but the first thing is going to be called result, the second thing mean, and the third thing SD. So now I run that same code and I look at result, and it's way more informative in terms of what we get back. And not only that, but I can use that $ notation with the completion that RStudio gives you to look at the different list elements that are returned. So that's a really useful thing to do, return a named list for your function. All right, so I mean, really that's the bulk of what you need to know. So what we'll do now is talk about other really useful things about writing your functions. So one of them is that there are these things called unnamed arguments. So you might have noticed when we ran mean, we saw this ... here. So that means that you can pass other arguments that might be used in other function calls within the body of this function that you're running here. Okay, so for instance, we're actually calling the mean function here, and we're calling the standard deviation function here. Well, mean and standard deviation both have optional arguments, right? We saw that mean had a trim argument. And so what we could do is put a ... up here in our function definition, and that ... allows us to pass unnamed arguments that could be used, say, in other functions within our main function. But let's look at that. And just to give another example of that, here's the mean function that has this argument that you can pass to it, na.rm. By default, that is false. And so if I tried to take the mean of a vector of values, so here's 5 random normal values combined with an na, the missing value, the mean of x would end up returning na because it doesn't know how to find the average of something that's missing. But we pass this argument in, and it will drop that na value and find the mean of the rest of them. And so we might want to add this functionality into our function as well. Another place where you see unnamed arguments would be, say, in your plot function. So we haven't really talked much about plot. We maybe ran one plot a while back, but this is the base R way of plotting, is just to use the plot function. It's a generic function. So again, going back to that object-oriented type business, it decides how to plot based off of the type of object you give it. But in the function definition, you can see that it gives a ... there. So it's taking in unnamed arguments. And so there are a whole bunch of different arguments that you can pass to customize your plot that don't show up in the main function definition here. So there's things like type, which tells you which type of plot you want, whether it's a histogram type plot, a dot type plot, or a line type plot. LTY, which is the line type, so a dashed line. And that can just customize what your plot looks like. So these unnamed arguments can be really useful for making your function very flexible. Here's the default plot function if you actually looked at it. So you can see that it has a bunch of different arguments, but then it also has that ... there. And you can see that, we called type and LTY. Type and LTY don't show up in all of these different things that you do here. But when they go in here and start talking about calling other functions, notice that they are using ... there, right? So this is allowing passing of unnamed arguments amongst these different function calls. So let's do it for our function, right? So SD has an na.rm option on it. Mean.default, which is what we're going to end up calling for our vector, also has an na.rm function on it, or option on it. So let's go ahead and allow that to be passed unnamed through our function. So all we need to do here is keep our original data, or sorry, original function that we wrote, but now in our inputs, we're going to put the comma ... And all we need to do is add it into here where we're calling mean and standard deviation. And what that's going to do is take the things that we give it here and allow them to be called in mean and standard deviation if they're applicable. And so, if I take some data that maybe has some missing values, so there's an air quality data set that I think is built into R, and there's a column on it called ozone. Let's look at that. Air quality, ozone. So notice that there are a bunch of missing values here. So if I try to find the mean of that, we're going to get NA. But of course, if I did na.rm equal true, we remove the NAs and we just find the mean of the rest of them. Well, if we tried to run our standardized function on air quality $ozone without putting in na.rm equal true, it would return NAs. It wouldn't work. In fact, let's go ahead and just do that. Let's find our standardized function here. Control R to send that to the console. Now I'll try to run, standardize on air quality ozone. Notice that it just returns a bunch of NAs because each one of these values got subtracted by the mean, which was NA, and divided by the standard deviation, which was NA. So it didn't work at all. But by now adding in this na.rm equal true, it knows how to do that. So it drops the ones that are NA, and does the appropriate standardization. And so, if you are trying to parse through the unnamed arguments that the user specifies to you, you can do so by doing list of ... within your function call. And so, for instance, we can look at this function just called f. That's going to take in x and whatever the unnamed arguments the user gives us. And what we're going to do is modify x and return x squared. And then we're going to also look at what the unnamed arguments were. And so let's see here, we're going to do f of x equal 10, and then we're going to give it a bunch of arguments that were not specifically asked for by the function. And so you can see it returned 10 squared, so that's good. That's our new x. And then we've now listed what's in the ... and we're going to return that as well. So now we have a list called ... that has A, it has B, and it has another list within there. So this is just to sort of expose you to the ways that you can get at what the user might specify for your function. So this is kind of interesting. So this is also telling you, by the way, how to access, say, this value from the response. So if I save this as an object to get at this vector down here, I would do that object $, $B, $char. So we're essentially going a bunch of list levels in to get to where we want to get to. Another thing you can do is just grab the names. So if that's useful to you, names is a generic function that will just grab the names of your list or data frame. And so we're doing the names of the list of ... So now if I do this, all that gets returned are just the names that the user gave those things. Again, that can be useful for determining what the user supplied you and what the user did not supply you. Okay, so I know that this is sort of upping the complexity of what we're learning in terms of R, but once you know how to write your own functions and read the functions that other people wrote, it really opens up the world of R to you. And actually in the next couple of videos, we're going to see that basically everything you do in R is a function call. Even your subsetting is a function call. When you do addition, that's really a function call. And so being able to fully understand this is going to help you overall in your data science workflow, because you're going to understand what these different functions and what R is doing as you go.